Hi everyone, I am here to discuss recursion and how we can build recursive functions to perform a task. So first, let us see what is recursion. Recursion is the process in which a function calls itself. A function calls itself. In your high school mathematics, you might have observed some recurrence relations. For example, one recurrence relation you might have observed in your high school mathematics is to define a factorial of n, you might have written this recurrence relation n minus 1 factorial multiplied by n, or simply n factorial is n multiplied by n minus 1 factorial. We can write it in either way. Then what is happening here? What is happening in a recurrence relation? Recurrence in the sense it repeats itself. So when you are defining a problem in terms of n, you are reducing the problem in next step to n minus 1. And the same process repeats with n minus 2, n minus 3 and so on until n becomes either 0 or n becomes 1. Okay, so we call this n equal to 0 or n equal to 1 as exit condition or stopping condition or base condition. Different people call them in a different way, but all these three are same. When you are defining a recurrence relation, you must be clear with the exit condition, base condition or stopping condition. What is the stopping condition? N equal to 0 or n equal to 1. Then every time, for example, we would like to perform or we would like to find out 5 factorial. This can be expressed as 5 multiplied by 4 factorial. What is happening here? N is reduced by 1 and the same process will be repeated. How to define this 4 factorial? This will be like 4 multiplied by 3 factorial. Then how to define this 3 factorial? 3 factorial is nothing but 3 multiplied by 2 factorial. And how to define this 2 factorial? 2 factorial is 2 multiplied by 1 factorial. Either we can stop at 1 or we can stop at 0. We all know the fact that 1 factorial is 1. Now this will be replaced with the value 1. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. And 5 factorial is 24 multiplied by 5, that is 120. This is the final result we get. So where did we stop here? At stopping condition or base condition. This is one important observation. So for a recurrence relation or recursive function, what is the fundamental thing we need to take care of? Base condition or stopping condition or exit condition. This is very important criterion to be taken care of. Next one, another one. You see, I have started with 5 factorial, then I went to 4 factorial, I went to 3 factorial, I went to 2 factorial, then I went to 1 factorial and then I have stopped. That means after every recursive call or after every call that we make to that term, that must come closer to the stopping condition or exit condition. Every recursive call should bring control closer to, should bring the control closer to base condition or stopping condition, whichever you would like to mentioned. Every recursive call should bring the control closer to the base condition. These two are the important things to be taken care while writing a recurrence relation or a recursive function. Otherwise, it will become meaningless and simply that will emerge or that will get into infinite loop. If any one of these criteria is missing, it will simply fall into infinite loop. This is the first thing you must understand. The recursive function came from the concept of recurrence relation in mathematics, and in computer science we call them like recursive functions, and each and every programming language will support this concept in the form of these recursive functions. Recursive functions. Now let me write that factorial function in Python. I will write this like def fact. It takes one parameter, that is n, fact of n. What is first? I must take care of this base condition. What is the base condition? Either you can stop either at 1 or 0. If n equal to 1, return 1. This is the base condition. Else, if n is not 1, then make a recursive call to the factorial. So how we will be making the return n factorial fact of n minus 1. Then in the driver code, if I call it like print fact of 5, I will get the answer 120. Okay, so this is how we write a recursive function in Python. Now let us experiment with another one. My task is to write a program. For example, the task is like write a program to print 1 to n numbers using recursion. We have to print 1 to n numbers using recursion. How can we do this? I will be writing a function def print 1 to n. I will name the function like print 1 to n. I will take one parameter, that is n. Then if n becomes 0, return empty return. This is empty return. Else print 1 to n minus 1 and print n. This is the recursive function. If I call from the driver code like print 1 to n 1 comma 20, what will happen? It prints from 1 to 20, 1 to 20 numbers. So how did I write this function and how does this work? Let us trace it. First, I am calling this function with the parameters 1 and 20. This takes only one parameter, that is 20. 1 is the obvious value, that's why we need not send that one. 20. We are calling that with the parameter 20. N is 20. We are calling this like print 1 to 20 and then 20. Is n equal to 0 here? No, it comes here. print 1 to n, it calls again print 1 to n, 1 to n, sorry, print 1 to n 19. Then followed by that there is one print statement which is nothing but print 20. Then this print 20 will not be executed right now until and unless the previous recursive statement is completely resolved. So many people will get confused over here. Students say that this code will print the numbers from 20 to 1 in a reverse manner. No, that won't happen. You have to clearly understand this. First, a recursive call is generated. Until that recursive call is completely done, it will not go to printing n, which is 20. Then print 1 to n, this is 18, and print 19. Still print 19 statement is not executed. That will be there placed in a stack. Next comes print 1 to n 17, then print 18, and so on it happens. At one stage this will be like print 1 to n 1 followed by print 2. Next stage print 1 to n 0 followed by print 1. Now what will happen? Print 1 to n 0. N is 0. It will return. It will not do anything. Then once this recursive statement is resolved, what is the statement that gets executed? Print 1. So 1 will be printed. Then print 1 to n, 1 is completely done. Why? Because this print 1 to n of 1 has generated two statements, 0, 1, and this is completely resolved. Next followed by print 2. 2 will be, print 2 statement will be executed. This is done. This is generated from print 1 to n of 2. That will be resolved. And so on, like print 1 to n 17, that might have been printed. Then after this print 18. These two statements are generated from print 1 to n 18. That is completely resolved. Then print 19. This is done. These two statements are completely done. These two are generated from print 1 to 9. That is completely resolved. Followed by that print 20. These two are completely done, and this is completely executed. Now the process is over. So this is how it prints the numbers from 1 to 20. What is the code? If n equal to 0, this is base condition. When n equal to 0, this is base condition. Then return, empty return. It will not return any value, just it comes out of the recursion. Otherwise, print 1 to n, n minus 1. For the first time it calls with 19, followed by print 20. So people will get confused that 20 may be printed immediately. No, that will not happen. So this until this recursive call is completely resolved, it will not go to printing 20. Okay. So this is how we can print the numbers from 1 to n using recursion. This is one important interview kind of question. Where they may ask, write a code to print 1 to n without using loops. So then you have to write this code. Okay. So I hope you are able to understand this recursion process a little bit. In other videos, we will come in detail with various recursive topics.